Hello, I'm Thomas with Geon Technologies, and welcome to the start of the Property Kind series, Configure. Overall, this series focuses on building a control loop from a node to a waveform using the various kinds of properties. In the node is a sawtooth signal generator device, and in the waveform is a simple controller component that will sweep through frequencies. The first two sessions of this series focus on lifecycle related kinds. Configure followed by exec param and allocation. For example, when a device launches, it is provided with its exec param properties and then called to initialize. After that point, it may see configure and allocate called many times over its life as waveform and component dependencies come and go. Similarly, a component will certainly see initialize and may see configure many times over its life. The third session will deal with using properties as asynchronous control words via the message kind. Before we get started, please take a moment to clone or download the code blocks repository on GitHub for this session. Specifically for this series on property kinds, you are given 4 Eclipse projects: a node, a signal generator device, a waveform, and the controller component. We will be updating each of these as we work through the series. If you have not already done so, import the projects as copy into your workspace. Here I've imported them by right-clicking on the project pane and selecting Import. I picked the download location and selected Copy Projects into Workspace. If you see this error, it's safe to ignore it. The goal of this session is to focus on updating the signal generator device with a configure property structure for managing its sawtooth output signal. Let's get started then by opening the sawtooth device's SPD project file. Then navigate to the Properties tab. This device has been written to use a structure called control params, which contains the frequency and amplitude of the desired output signal. So let's add a struct property whose ID will be control params. You'll notice its default kind is configure. This kind indicates that the property's value can be set as part of the parent node or waveform preferences, as well as at runtime from the SCA Explorer, the IDE, or even from the Python Sandbox, as long as it's writable, of course. Since this is a structure, any properties within it are also of the same kind. In this case, we need 2 simple properties: amplitude and frequency. Both should be of type float with initial values of 0. And a quick pro tip for you here: right-click on the structure to quickly add to that structure. All other avenues result in having to create and then move properties into the structure. Since we did not specify a name for any of these 3, the ID will be its name. Regenerate the implementation and open the sawtooth device py implementation file. It's time to get a lay of the land for this device. Towards the bottom is the getData method. Anytime the internal signal is empty, none, this method generates a new signal. Thereafter, it returns a narrow sliding window of the samples to get a nice smooth output for the sawtooth. Above this method, you can see the end of our service function, process, where we call getData and then push out our bulk I/O signal. Towards the top of the class, you can see that this device will indicate a usage state of busy if running and idle otherwise. We also have a simple method for verifying incoming frequency values to ensure we are meeting the Nyquist sampling rate. Let's take a moment to test our device in the Sandbox. Throughout this series, we'll be using the REDHAWK 1.9 Python Sandbox rather than the one integrated in the IDE because the difference is in features. For example, the ability to launch a device within the Sandbox session. Open a terminal and navigate to the sawtooth device's path. Then open your Python shell. From ossie.utils, import SB, the Sandbox. Use the Sandbox's launch command with the relative path to the sawtooth device's spd.xml file as you see here. Here we're going to also specify initial configuration parameters for amplitude and frequency, so that the device starts with initial values, other than 0. Next, create a line plot and connect the sawtooth device to that plot. Finally, start everything using the Sandbox's start method. So, here's our sawtooth. Amplitude 10, frequency 500 Hz. Let's change the amplitude by issuing another set of values with the configure method. And nothing changed. Use the Sandbox stop method to bring everything to a halt. And if you like, exit the Python shell. We need to make a small edit to the sawtooth device. To capture calls to configure a property, we need to implement the configure method in our class. Over the life of a device or a component, it might be commanded several times to reconfigure a property, and this command is always issued through that configure method. And since this is Python, though, we can implement an onConfigure method to capture the specific property changes. Let's do that now with the onConfigure control params method shown here. This method validates the new value against Nyquist, and if it's valid, clears the internal signal. The next time getData is called, a new vector with new control params values will be created and pushed into the system. Let's prove it by repeating our earlier Python sandbox process and changing the amplitude. I've gone ahead and sped up this portion since the commands are identical. And now for the new amplitude. Done. Our device now accepts commands to reconfigure its control parameter structure. Alternatively, we could have deployed this as a device in a node and then modified the device's properties either from the IDE while the node is online or from the sandbox. The result would have been the same. And that brings us to the end of this short session on the configure property kind. As a reminder, some of the key points to this kind are: configure can be used in conjunction with exec param and allocation, if appropriate. The device or component receives calls to configure a method related to these properties. A device or component may be commanded to configure many times over its life. And as always, properties are identified by the ID, not the name. Thank you for watching. My name is Thomas with Geon Technologies. Please don't hesitate to contact us for more information and in-class training.